Good day. We're looking at electrolysis. Electrolysis involves electrolytic cells. So let's first of all get a definition. Lysis means to split. So electrolysis traditionally meant to take a solution, an ionic solution, zap it with electricity, and break it down, decompose it. For our purposes though, electrolysis is always going to involve non-spontaneous redox reactions. So electrolysis in a sense is a reverse of electrochemical cells. In an electrochemical cell, we're taking chemicals, we mix them together, and we get a spontaneous reaction. That reaction produces electricity that we can use in the form of things like batteries. On the other hand, electrolysis, we're taking a non-spontaneous reaction and we're putting electricity into it to make that non-spontaneous reaction occur. So these things always have a negative cell potential and we have to put that voltage in to force them to happen. There are some advantages to it. Well, electrolytic cell, it has an anode, has a cathode, has electrolyte, and a wire, just like an electrochemical cell. The anode is still the site of oxidation, cathode is still the site of reduction. So that stuff doesn't change, and that's fantastic. So here we've talked about how it's a reverse electrochemical cells. It's got non-spontaneous reactions. That means a negative cell potential that we have to overcome, and we apply that voltage to make it happen. But the nice thing is oxidation always happens at the anode. Reduction always happens at the cathode. Electrons always flow from anode to cathode. So that's all the same as before. The anode has a positive charge. We're actually going to control that. We're going to set it up to make sure we hook up the anode to the positive part. And that way it attracts the negatively charged anions. Remembering from grade 9, opposite charges attract. Cathode is a negative charge to attract the positive cations. All right. We're going to look at type 1 cells and then we'll wrap up this part or this video because I have to do a diagram and make a video of that. Type 1 cell is the simplest of the electrolytic cells. That's why we love it. It has a molten electrolyte. Molten means it's been heated so much it's melted, so we don't have to worry about water to have our ions. It has inert electrodes. Inert means don't react. So carbon and platinum are commonly used, maybe carbon more often because it's cheaper, but these are simply solids that conduct and allow to be a site for reaction, oxidation, reduction to happen. So there we go, molten, inert, don't have to worry about reaction there, don't have to worry about water. The only thing possible to happen is a reaction of electrolyte. Now this would be sodium 1+, so the only thing that can happen to it is it can reduce at the cathode. And here we have chloride, Cl1-, and all it can do is oxidize at the anode. So in the next video for the type 1 cell, you'll watch a whiteboard diagram that's in a video of some sort, and that will illustrate a type 1 cell for you. And you'll move that video now.